welcome to what is going to be one of your many lessons in algebra and geometry in preparation for physics and other subjects. Without further ado, let's get started. Alrighty, let's dive into our first lesson, which is the introduction to polynomials. A polynomial is just a sum of the terms in the form k times x to the n, where k is the coefficient and n is a non-negative number. A constant term is a term with a number on its own. A monomial is a polynomial with one term, and a binomial is a polynomial with two terms. A trinomial, three. And the degree of a polynomial is the highest power of x in the polynomial. The leading coefficient is the coefficient of the term with the highest degree. In standard form of the polynomial is where the polynomial terms are arranged in order from highest degree to lowest degree. All of these are some great examples of polynomials. Now let's try an example problem. A polynomial of the fifth degree with a leading coefficient of 7 and a constant term of 6, and you're asked to pick the expression that matches this description. Well, you know that the degree is 5, you know that the leading coefficient is 7, and you know that the constant term is 6. Let's first pick out the degree, these polynomials by degrees. Well, the degree is 5, meaning that the term with the highest degree is 5. With the highest power is 5. So you can immediately eliminate B and C since they both have degrees 6 and 7 respectively. The leading coefficient has to also be 7. So, and for that reason, you could eliminate D, since the leading coefficient of D is 6. We're left with only A as the option. And if you'll notice, the constant term is indeed 6. So A matches up with all the criteria. The average rate of change of 2 points on a polynomial is just the slope of between those 2 points. For example, if I have a polynomial, f of x equals x cubed minus 4x, and you're asked to find the average rate of change of f on the interval -2, 3, well, the average rate of change will just be 3, since f of b minus f of a, so f of 3 minus f of -2 would just be 15, and you divide that by b minus a, which is just 5, and you'll get 3. Now let's talk a bit about adding, subtracting, and multiplying polynomials. Now it's important to combine like terms when you add or subtract polynomials. So I've labeled terms at the same degree in the same color. After combining, for the first one right here, you'll get 7x squared plus 14x minus 3. Similarly, if you combine like terms for the second expression, you'll get negative 7x squared plus 12x minus 3. Now let's talk a bit about multiplying polynomials. Multiplying monomials is easy. You first multiply the coefficients, then you multiply the variable terms. For instance, 4x times 5x times 6x will just be 120x cubed, since 120 is 4 times 5 times 6, and then multiplying the variable terms, you get x cubed. Your final answer is just 120x cubed. Similarly, 5x squared times 3x to the fifth is just 15x cubed, since multiplying the coefficients, you get 15, and then the variable terms, you get x to the 7th. Remember, x squared is equal to x times x to the fifth is equal to a string of 5 x's multiplied by each other, so x squared times x to the fifth is just x to the 7th. In general, when you have a two terms multiplied by each other like this, x to the a times x to the b, you'll get x to the a plus b. Perfect. Here are a couple examples. Please try them and pause the video. I'll be going over them later. Let's start with the first problem. 6x plus 5 times 6x plus 5. The first terms in this instance are 6x and 6x. Multiplying them together, we get 36x squared. The outer terms in this instance are 6x and 5. Multiplying and adding it to the list, we have 30x. Inner then is 5 times 6x. Outer is 5 times 5. And then after combining like terms, we get 36x squared plus 60x plus 25. This is your answer. Now let's do the second question. 55x plus 6 times 7x plus 2. The first terms in this instance are 55x and 7x. Multiplying them together, you get 375x squared. The outer terms are 55 and 2. Multiplying those together, you get 110x. And then the inner terms, 6 and 7x, you get 42x. Finally, the outer terms, 6 and 2, you get 12. Adding these three together, you get this simplified form. 375x squared plus 152x plus 12. Here are some special products of polynomials. When you have a plus b times a minus b, that is simply just a squared minus b squared. This is called the difference of squares. When you have a plus b squared, which is equal to a plus b times a plus b, you get a squared plus 2ab plus b squared. When you have a minus b squared, which is a minus b times a minus b, you get a squared minus 2ab plus b squared. I highly recommend that you memorize all three of these formulas. Below are some more complicated special products of polynomials. These are just mainly for fun, and you don't have to memorize them. But nevertheless, they are still sometimes important to learn. Now let's see some examples. When you have 3 plus 5x to the fourth times 3 minus 5x to the fourth, you can immediately recognize that this is a difference of squares. So instead of doing the FOIL stuff, what you could do is just know that it's the first term squared minus the second term squared. And this is going to be your end product. Remember, as always, x to the a times to the bth power is equal to x to the a times b. The second example that I have is 125x cubed minus 27x. How would you factor this? Well, this is a bit more some more complicated, as it is one of these three right here. Can you figure out which one it is? If you said the second one, you're absolutely correct. And when you factor it, you'll get 5x minus 3 times 25x squared plus 15x plus 9. Once again, these are the main special products that we use. Now let's try some challenge problems. Expand this one right here. Don't immediately look at the solution. Pause the video and try give the problem a try. Okay, perfect. To do this question, we have to do a more advanced version of FOIL. The key concept behind FOIL is you multiply each term by the entire second term individually. So for instance, you could also write it out like this, expand it out like this. X squared times x squared plus 5x plus 4 minus 8x times x squared plus 5x plus 4. And finally you have 12 times x squared plus 5x plus 4. Multiplying everything and simplifying everything, you get x to the fourth minus 3x cubed minus 24x squared plus 28x plus 48. Here we have another challenge problem to do. Again, pause the video and don't look at the solution immediately. I hope you've paused the video. Now I'm going to solve this question. To do this question, you first multiply this term by this term, this term by this term, and this term by this term. And then you'll multiply this term by this term, this term by this term, and this term by this term. Finally, you multiply this one by this one, this term by this term, and this term by this term. So a lot of stuff to keep in mind. Let's start with this term right here. You have to multiply it by each of these three right here. So starting with this inner one right here, you'll get 6x squared. Moving on to this one, you get 24. Sorry, this is 6x to the fourth power. You'll get 24x cubed. Finally, you get 24x squared. And then doing multiplication of this term by this term, you'll get 30x cubed plus 30x squared plus 30x. And you'll get, multiplying this term by all three right here, you'll get 18x squared plus 18x plus 18. Perfect. Now it's time for combining like terms. I'm going to label all the like terms with the same color. Here are all the like terms. After combining, you'll get this. Perfect. This concludes our first lesson. Thank you so much for watching this video, and I'll see you guys next time.